Good afternoon, everybody. Welcome, welcome. This is Kristen Galden with Hand to Mind. We are so excited to have you here today. I am actually not going to be the one presenting to you, but I do want to go over a couple of housekeeping logistics things here before we get started. So first, this is your attendee panel. So your attendee panel is limited. You're not able to see other people and what they are chatting, but you are able to send questions to us. So we have it set up this way just because of the number of attendees. You're also going to remain on mute. So questions or comments throughout the presentation today. There will be a couple times where Michelle, stops and asks a question. So please put those in the question box and she will be able to see them. And also we'll do a live Q&A at the end with Michelle. So any questions that you want me to ask aloud, we will flag. So go ahead and put them in throughout the presentation and we'll see them. And she can answer them at the end. Also, the computer audio typically is what it defaults to, but if it doesn't or you're having trouble with that, just switch over to the phone call. And then a number and an access code and a PIN will come up and you can put those in. To go over the email that you're going to receive. So at the a few hours after we're done today, you're going to get an email from me, but it's automatic. And this email contains two things, the recording and it contains a certificate. If you are watching this webinar recorded later and are not on live, you do not receive a certificate. The certificate is only sent to those who are attending the live webinar. So I have to say that. But you can access these. It's just a PDF and it shows that you attended a 1-hour webinar with Hand to Mind and it gives the date. So feel free to download that and try to submit for PD credit. Many will give credit for these webinars. On that note, I am going to pass things over to Michelle here in just a moment. I want to ask you first if you do math talks and number strings. So just do a quick poll. This should pop up in your attendee panel. There we go. So just very quick, are you doing these already in your classroom? Yes or no? And that will give us a better idea of who we have in the audience today. So let me give you just a few seconds to do that. Do the Jeopardy tune. Okay, I'm gonna go ahead and close it. So we look to be about 58%, 60% say yes. And the others say no, so about 40% say no. Okay, so today we have Michelle Reinhart. Michelle is a former teacher. She is also a math specialist and she is currently getting her doctorate at Harvard. So yay, Michelle, that's very impressive. I am making you the presenter right now. So you should be seeing a pop-up on your screen to show it and we can see your video.
Okay, perfect. Thank y'all. Okay, well, hello, welcome. I hope you are all doing well. I'm actually going to turn off my camera video here in a minute. I just wanted to say hello before I turn that off. I'm going to turn it off so that we'll have better bandwidth for the document camera and the presentation. But I'm so glad you're all here, so welcome. Okay, we are going to jump right in. I'm so excited about the poll results showing that about 60% of us are already using some forms of numeracy routines in the middle grades and are here to learn more, and others are here to learn what might this look like and how might this work and fit into what we do in our classrooms and in our schools. So I will jump right in. I'm going to have us start by thinking about this equation. 2/3 of some number minus 5 equals 7. And I want us to think about how our students currently maybe approach this equation, maybe with some trepidation because there's a fraction, and even worse, it's divisible by 3. And a two-step equation, so maybe this is 7th grade, 8th grade on up. How do students reason about these equations? And so I want us to start by thinking about a potential pathway that students might reason through this equation, and then think about what might it take to develop numeracy and mathematical flexibility in our students so that they can develop that kind of thinking. So here's a pathway that students could use to use reasoning to solve this problem. They could maybe think about like looking at that in its entirety, it could be a mess or overwhelming, but I could maybe kind of cover up that first part of the equation and think about, this is basically saying that something minus 5 is 7, right? And so then when I'm looking at that, I'm like, oh, well, that's actually a fact I know. I know that 12 minus 5 is 7. So whatever is under that blue, cover up, if you will, must be equal to 12. And so I could kind of think about that being true and then kind of uncover, if you will, and say, so therefore 2/3 of x equals 12. So we've kind of simplified maybe the first part of that equation. But then what would it look like to reason about this kind of equation? And my goal is that by the end of this webinar, we're able to look at this equation and think of it maybe as, well, if 2/3 of some number is 12, then couldn't we think of 2/3 as 2 1/3? Would that be true? So like if 2 1/3 of a number is equal to 12, then 1/3 of that same number must be 6. This is not kind of an automatic skill, but this idea of how could we develop this ability to iterate and partition flexibly to say if 2/3 of x is 12, I could partition that down to say that 1/3 of x must be 6. And from there, if I know that 1/3 of an x is 6, couldn't I iterate that up 3 times, triple that, to give me that 1 whole x is 18? So I share this not as like, okay, so here are the new steps that we need to memorize and do when solving equations, not at all, but instead to push us to imagine what might it look like to solve a 2-step equation with rational coefficients using reasoning. Imagine our students using that kind of mathematical flexibility, and then how could we use numeracy routines to get them there? So that's kind of an arc, if you will, for our time together. So here are the guiding questions that are going to drive our session today. We're going to look at why would we use numeracy routines in middle school mathematics, and we have a blog post that'll be dropping next week about this very topic. So if you're interested in that or sharing that with your colleagues, watch for that. Also, we're going to look at how, specifically in this webinar, so how do we do that? How can we actually use number strings to develop mathematical flexibility and strategies? And then later we'll look at math talks as well, kind of look at the similarities and differences between those. And then explicitly, we're going to look at the pedagogy behind this, like what teacher moves make number strings effective, both face-to-face and online. And I'll be modeling some of those live for us. And I encourage you throughout the session to use that question drop box like a chat. You can send affirmations in, you can send your answers to questions in, and you can send questions in as well. Okay, so here's kind of an overview of where we're going. And I always overplan, so we get through what we get through, but we'll never run out of stuff. And so here's where we're going. We've already kind of imagined what solving equations could look like with reasoning. I'm gonna lead us through a sequence of number strings that will show us what this could look like and feel like in a middle school classroom to develop to that level of reasoning. And then we'll kind of step out of it at the end and talk about teacher moves, things that you've noticed and observed throughout the session. So with that, we are going to start with equivalency. And so I'm going to hop over to, give me just one second here, hop over to my document camera. Kristen, if you don't mind, or people can share in the chat as well, or the question section, can you see my document camera okay? If so, you can kind of see my hand, see a marker. Is that working okay? Yes, awesome.
Yeah,
appreciate
I can see your hand and the page looks good.
Awesome, thank y'all, appreciate it. Okay, so we're gonna start by thinking about equivalency here. So say, for example, we're thinking about a number like 1/5, and we're wondering what's the decimal equivalent of 1/5, right? So we could start with that. Students could kind of pull back on some of the fractional reasoning they've done in previous grades. Some students might kind of know that with automaticity, but if we didn't know that, we could share like, how do you reason to find the decimal equivalent of that if you don't just have it kind of memorized in your pocket, so to speak. So some students might share about, they maybe think of that as 2/10, and 2/10 they know as the decimal 0.2 or 2/10 written in that form. So it's like a way we could get there. We could look at 100 grid or a 10 by 10 grid here and think about like, what does 1/5 of it look like? Lots of like work we can do on this first question to connect this back to multiple representations. And once we've done that, I want us to think about where we can go with that. So for example, we could then think about like, okay, so 2/5. If I know that 1/5 is 0.2 or 2/10, what would 2/5 be? And again, you're welcome to kind of share into the question section as we go. And I want us to think about how, if this is one we didn't have memorized, some of us might just be like, oh, it's 0.4, that's just one I know. But if it wasn't one that I just kind of knew, if you will, I could think of that as 2/1/5. Yeah, like 2/5 is 2/1/5. And since we know that 1/5 is 2/10, I could say, okay, let's just double 2/10, and that would take us to 4/10. So that's like another way I could get there if I didn't have 2/5 at my disposal. Okay, next question is string. We could then think about, what about 4/5? What about 4/5? And if you will take just a second and share in the question section, like what's a way that a student could reason to that based on what we've done so far to find 4/5 as a decimal equivalent? Yeah, thanks. I'm seeing Amanda sharing, like you could think about that as 4/1/5, right? 4/5 is 4 iteration of 1/5. Yeah, so that'd be like 4 times 2/10, which would be 8/10. Awesome. Yeah, Angie's saying, oh, or they could double the one before. Like, isn't 4/5 the same as double 2/5? Yeah, and we knew that 2/5 was 4/10. So, oh, sure enough, that'll get us to 8/10 as well. And so we're seeing kind of the flexibility that when we get to this third problem in the string, there were actually multiple ways to think about it, but they both used this idea of like iterating and partitioning strategically. Awesome, thanks for that. So let's see kind of where this continues on to. So our next problem in our string is 1 3/5. 1 3/5. Again, we could ask students, okay, so like, how are you thinking about that? Give everyone, 20, 30 seconds to think on their own. If we're live, we like in person with students, we could be using like a signal, like a thumb on our chest to show when I have an answer. If we're in Zoom or Google Meets, we could be doing like a raise hand or another like thumbs up icon to see when people are ready. And again, thinking about how would you put into words like you're thinking here. And so on this one, we might have some students who share that they actually thought about like decomposing that, like 1 3/5. And then for the 3/5, maybe they thought of that as 3/1/5. So that would be like 1 plus 3 times 2/10. So this would get us to like 1.6. Again, they're not necessarily like writing all of this down, but we're trying to capture on paper what students might be doing in their heads, right? Kind of setting the 1 aside, reasoning about the 3/5 as 3/1/5, kind of putting those back together. I also see some of y'all are thinking about that as, oh, my brain kind of went to like an 8/5 there or whatnot. I did see a comment in the Q&A about audio, so I'm just doing a quick audio check. If you can hear me, can you just type into the chat or the question and answer for just a second? You can hear me? Thanks, Gary, appreciate it. So I'm sure that Kristen and team will be helping people who don't have audio. Thank y'all for checking in, appreciate y'all. Okay, one last question that I'll just kind of plant the seed for in this string. So this is the 5th question in this string is, so then 11/5. 11/5. How are you making sense of what that would be as a decimal equivalent, if you will? Okay, so you can, again, think about that. Again, throughout the session, whenever I ask a question, you can be talking aloud to yourself. You can be entering your answer into the Q&A section. Everyone a minute to think about how would you find the decimal equivalent of 11/5? Awesome. Yeah, seeing lots of different ways people are thinking about this. So I'm kind of predicting 2 strategies that would maybe come out. Maybe some of us would think about this as 11/1/5 as a way we could think about that. Yeah. And some others you were thinking about like 11/5 as, it's like tricky for me to say today, as 10/5 plus 1 more 5th. Like you could actually decompose that 11/5 into 10 of them and plus 1 more of them, which would be 2 and 1/5, which would be 2.2. So it's like another way. Hold on to this idea about like decomposing fractions like this. So that's going to come back up later in the session. So this is a quick like dive right in and look at what is a number string? What might it look like and feel like? What kind of strategies might we be developing here? I might push you to think about and try to put into words like, what do you think, like what strategy are we trying to develop here? What skill are we trying to develop here within this particular string, right? Like, yes, we were finding decimal equivalents, but we were doing it in some very deliberate and specific ways. Give you just a minute to kind of think about that. Awesome. Yeah. So first of all, question Jessica asked: should we be able to see the chat so you can see other people's responses? No, the way the webinar settings are set up, you answer or you enter into the Q&A section your chat responses, and then I can kind of narrate them back out to y'all. So you shouldn't be able to see them all. So thanks for that question. Angie was sharing, it's like we're learning how to decompose. Yeah, absolutely. So we're decomposing strategically, we're partitioning sometimes, breaking into pieces. We're also iterating back up, like this idea of 4/5 as 4 1/5 or as 2 2/5, kind of developing that flexibility to think about numbers in different ways. Before we move on from this string, I want to show you like where it came from. And so here I have, this is my set of cards from the Daily Math Fluency Kit for 6th grade. And you'll see on this card set that on the left, we have the 5 problems that we worked through live together. In the middle is kind of this back and forth between teachers and students, gives you an idea of like what is the conversation that we're going for here, what are the strategies we're looking to elicit and draw out. And then on the right side is a sample of like, here's a way we can kind of record this thinking as we go. And so if you see, you'll see that we actually, our notes ended up being pretty close to what's over here on this right-hand side. Even though we did this string live together, it was designed in such a way, and the questions that I asked elicited this kind of trajectory or storyline throughout the string to build to that big idea. Yeah, I love that, Jane. Jane was saying one of her takeaways from this string was this idea of like multiples of what we know, that to find 11/5, I could think about other things that I knew and use what I know to figure out a decimal equivalent for that one. Awesome, love it. So thank you for engaging in that one, kind of equivalency. We're kind of setting some building blocks, if you will, for other middle school content we will get to shortly. I'm gonna set that one aside and pivot to our second topic. For this one, I'm just going to kind of overview it quickly. I'm not going to lead the whole string live. I want to get to some other strings about division and then also like ratios and solving equations. But I want to show you this because I think it builds another specific skill set that's interesting as well. So this string is called locating numbers. And here's how it starts. I would start by drawing a relatively straight-ish line. So something like this. And I'm going to put on this number line the numbers -4 and 2. -4 and 2. And then my question on the first question of the string is, where is 0? Like, where would 0 go on this number line? And you can think to yourself, like, you're probably like, oh, looking at your screen, it would go right there, and you're pointing to somewhere on your screen. But how would you put into words like your strategy for finding out as closely as possible where it is, right? So think about that. How would you put into words your strategy for kind of getting to where 0 is? So here are some examples of what you might be thinking. Your brain might be thinking about like, okay, well, how far apart are -4 and 2? And some of our brains might be thinking like, oh, those are 6 units apart. So I could divide this up into 6, not bad off the cuff, into 6 kind of congruent spaces, if you will. And that would be 6 units apart, and then I could kind of label the spaces. Some are saying, ooh, I thought about maybe not partitioning it by six. Sorry, that's tricky for me to say too, but I thought about partitioning it by thirds and then labeling, if you will, the different thirds, and then sure enough, there's 0. So this idea about like how you partition and how we can build those muscles about partitioning is a really, really important skill for students to learn. And this idea of strategically drawn number lines where there are some numbers on them, but then you have to kind of partition and iterate to find what you're looking for can be really powerful for that. Let me just show you some other questions in the string. We won't kind of engage in them, but here's the next question would use the same number line and have students think about, okay, well, where would +4 be? And then how would you put into words like how you got there? I'm thinking some of us might iterate up from this +2, but some of us might think about, oh, well, I know that -4 is exactly opposite +4 in terms of 0. And so kind of use that reflection. And then -12, where would it be on this number line? So again, you could be thinking about how would this be, maybe developing strategies for students of, if my strategy had been to count by individual 1 units, that's not very efficient many times. And so how might these questions kind of be nudging students to think in bigger and bigger jumps so they can think and reason more strategically. So this particular string goes on and has like a second component of it, another number line that includes -9 and -3, and then asks students to think about, okay, so where would 0 be on this number line? And where would +6 be on this number line? So I want you to think for just a minute about like what kind of skills might a string like this develop for middle school students, right? What kind of skills might this develop for middle school students? If you'll take just a minute or so and type some of your thinking into the Q&A section, how might a string like this, where on the surface it's like, oh, we're just putting numbers on a number line. But like, what's this getting at? Where's this going? Love it. Y'all were like instantaneous. I like so much. And so you're still typing, which is great. This idea of like scale, making appropriate scales. That's nice too. That idea of like, is it always most efficient to go by ones? How do you know? How do you decide? Proportionality, relative magnitude. Nice. Getting into that like absolute value idea. Integers, ordering numbers. Like how might this be laying a really powerful foundation for that, as well as this idea of distance, etc. Okay, we won't go further into this string. There's actually a follow-up string that starts with, that actually moves into fractions. So what if this time we had a number line that, I'm trying to think which one of these I want to show you. Oh yeah, let's do this one. This is later in the next string, but it just kind of gives you an idea of where this could go. That has, say we know -1/4 is there and 3/4 is here. I'm going to extend this number line over this way too. And what if this was our number line and we had to figure out where to put -1, like as exactly as possible on this number line? So again, thinking about, and there's other like fraction problems we can add as well, but how this is getting students to think about partitioning and iterating numbers, as well as values of numbers in much more flexible ways that will help in other parts of middle school mathematics as well. Yes, Jamie shares, this is like number sense, absolutely, and it's rooting it in a visual model that helps us make sense of that and develops other skills, specifically this idea of like partitioning, cutting into pieces, and then iterating back up, that will be useful in other contexts. Okay, awesome. So I'm gonna kind of pause this there, but just note that, again, there are particular strings in this resource about locating numbers, about comparing numbers, and hopefully this gives you an idea about another kind of routine you can use where you're giving a strategically created number line and then asking students to iterate or partition to other values as well. Okay. let's continue on our trajectory to see where this goes. I'm going to actually have us do a math talk for just a minute. And this is a math talk about a concept we haven't looked at yet in this webinar, totally fine. But we'll just see kind of what ideas we bring to this question already, and then we'll talk about how math talks can typically work. For this particular math talk, I want us to think about this division. 168 divided by 7. 168 divided by 7. And what I'd like you to do is, I'd like you to, if there's part of you that's like drawn towards the traditional division algorithm, try to just mute that part for just a minute, push pause on that part for just a minute. And I want you to think about how you could reason to figure out that quotient. What's 168 divided by 7? How could you, as someone shared earlier in this webinar, use other things that you know or other facts that you know to kind of get there? So I'm going to pause for a second, give you a little bit of think time. And again, you can jot down on paper or try to illustrate your thinking. How can we kind of illustrate 168 divided by 7 with reasoning? Now, y'all, if you're like me from a few years ago, I would have been like, I can't. I can reason through the steps. Like I can show you how to set this up and tell you all the steps to do, but like I don't understand how I'm supposed to just like know that. And so like if that's resonating for you, you're in good company. Let's kind of look at how could we build those muscles around reasoning. So Cynthia shares her brain went to like, oh, I don't know, 168 divided by 7. Like that's not one I have in my pocket. But she shared that she thought about a different fact instead. She actually thought about, well, I know 140 divided by 7. 140 divided by 7. So I'm going to go over here and I'm going to write this 168 divided by 7 a different way. So another way we could write that is 168 divided by 7, right? We can write that as a fraction. And those mean the same thing, right? This division symbol, that's another way we can write 168 divided by 7. So it sounds like Cynthia was thinking about this as 140 divided by 7. Yeah, and Cynthia, let me know if I'm on the right track here. And then, but you have another, what's the difference there? Another 28 divided by 7? Does that work, y'all? Can you do that? Can you write 168 sevenths as 140 sevenths plus 28 sevenths? Yeah. And that actually relates back to what we did earlier. Didn't we think about, oh, like I told myself earlier, you're going to put these papers down and need it later. Didn't we think about 11 fifths as 10 fifths plus 1 fifth? Like you can separate them out like that. You can decompose 11 fifths like that? Absolutely. So 168 sevenths, if you will, or 168 divided by 7, we could think of as 140 divided by 7 plus 28 divided by 7. Oh, those are much friendlier to think about. Is that something like 20 plus 4? So this quotient must be 24. Is that a way we could kind of make sense of that? Yeah, and I'm seeing lots of others sharing in the chat that their brain is starting to think that way as well. This is absolutely not the only way we could think about this problem, 168 divided by 7. There are other ways as well. Some of y'all shared them in the chat. I wanted us to look at this idea about, this is called partial quotients. I'm gonna write that down. Partial quotients. The idea of taking a quotient and strategically decomposing it. Strategically, right? We could have decomposed this into 167 sevenths plus 1 seventh, but that wouldn't have helped us very much. This is a very strategic decomposition that helped us reason about this overall quotient more efficiently. So this is a quick view of a math talk, except in a math talk, we would have multiple strategies come up for this. We're going to do another math talk later. But what I want us to see is like, so how would we get our brains to do that? Like if my brain didn't do that yet, didn't yet think about, I don't know 168 divided by 7, but I know 140 divided by 7, how might we nudge our brains to think like that? And that is the power of a number string. And so here is a number string that builds to this exact problem, 168 divided by 7. It has students think about 80 divided by 8, models that. 24 divided by 8 models that, has questions that kind of scaffold this, and then have students think about 104 divided by 8, which could be decomposed into this 80 divided by 8 and 24 divided by 8. And then kind of shifts gears to this 168 divided by 7. The point I'm trying to make here is that one thing that we've seen happen with math talks kind of at large, especially in elementary school and then in the middle schools that are using them, is sometimes we think, hey, if we just ask a question like this, students will come up with all these ideas and different strategies naturally. Sometimes yes, but there's so much power in leading strings that help students play around with a new strategy, develop a new strategy, kind of nudge them towards it so that they can then begin to like practice that, put it in their toolkit, and implement it going forward. So just as a way to think about the role that number strings help us develop strategy, and then math talks help us kind of apply strategy and compare and contrast strategies towards efficiency. Okay, thank you for all your thinking on that. Love it, love all the insights y'all are sharing in the Q&A section, so keep it up. I'm gonna pivot us to two more things to kind of think about here. Next, I want us to dig into ratios for a little bit and think about, okay, so we've looked at different kind of reasoning you could use with fractions, decimals, and percents, with comparing numbers on a number line. We looked a little bit at this idea of like division and how you could even reason with division. That might have us thinking about, can you reason with division of fractions and division of decimals? Like absolutely, so hopefully that's planting some seeds. Where I want us to go next though is to think about, getting myself together over here, y'all. To think about, can we reason with ratios? What does it look like to reason with ratios? So let me start with this context. Let's say we're talking about buying freezies. And I will tell you, this problem was not written today, because if you are in Texas with me, if you're here in Texas or somewhere close to West Texas, we are getting like our 1 day of winter today. We're not taking it well, y'all. Okay, so freezies, let's say we're buying some freezies, and say we know that 21 freezies, we get a pack of 21 for $30, okay? And I wanna know, okay, I don't have that much, but assuming I can buy them at this like similar rate, if you will, how many freezies can I buy for $10? How many freezies can I buy for $10? So take just a minute and think about, okay, what's your brain doing or kind of telling you to do or nudging you to notice in this particular situation? Oh, awesome. Some of y'all were just like, oh, it's 7. Nicole was saying she thought about like dividing by 3. So maybe she thought, oh, like you have a third of the money, and so you can only get a third of the freezies. So that would be 7 freezies. Yeah, absolutely. That's a way we can think about it. Love it. Thank you. Thank y'all for sharing your thinking on that. Okay, same situation, same store, same kind of pricing structure. But now for some reason I have $100 and they're going to freezies, and they're going to freezies. How many freezies could we buy with $100? With $100, how many could I get? Yeah, and so we're like, oh yeah, 70. Like this is, how did you get there? How were you thinking about that? And again, when we're either face-to-face with kids or like I say live, but like live online, Zoom or in a Google Meet or whatnot, that follow-up question, like explain your thinking, not just what is your answer, but how did you get there, is so critical. So that's when I call on a kid to be like, okay, so you think it's 70, tell us how. Okay, so some of y'all are saying that you're thinking about like, oh, this is, you've got 10 times as much money there, so you'd have 10 times as many freezies. Okay, that would be 70 freezies. Totally makes sense. Thanks for sharing your thinking on that in the chat as well, y'all. So here's my question on that though. Like, how would you explain, like, it seems like almost everyone used this column to help us answer this last question. But I'm wondering, like, how would we describe going from here to there, right? Like, it doesn't look like anyone went straight from $30 to $100, right? It seems like we all went through this 10, and I'm wondering why that is. Like, just because it was right next to it? So I got some thinking too about, like, why didn't we just go straight from 30 to 100? Or could we have? Love it. Love y'all sharing in the chat. Thank y'all for that. Nicole's saying, like, we could have, like, there's something we can multiply 30 by to get to 100. She says it's like 10/3, which feels kind of yuck. Yeah. So she's saying, like, that wouldn't be easy. 10 is really friendly. This was easier to think about. I'm kind of putting into words the different things that y'all are sharing in the chat. Someone shared, Claire shared, I would have gone down to 10. So we started at 30 and went down to 10 in order to get to 100. That felt like an easier path. So you kind of like scale down so that you could scale up more easily. Interesting. Okay, let's kind of hold on to that for a second. Next problem in the string. What if this time we had $80? What if this time we had $80? How many freezies could we buy this time? Awesome. Loving how y'all are thinking about this. Some of y'all are thinking about getting to 90. Some of y'all are like, oh no, that 10 is still really friendly for me. Lots of different thinking about this one. I'm going to leave this particular question in the string open. This is the third question in the string. Each string is designed to have 5 questions. This was like our first question. This was our second question. This was our third question. And I'm going to kind of pivot us just to look to have a sample of where questions 4 and 5 go in this particular string. So again, back to our summer context when these were written. This time we're going for ice cream sandwiches. Some kind of party or something. Ice cream sandwiches, and we know that 12 ice cream sandwiches cost $15. 12 ice cream sandwiches cost $15. And here I want us to try to figure out, okay, so how many ice cream sandwiches could we buy if we had $25? How many could we buy if we had $25? Y'all, don't rush this. I want to see, like, where's your brain taking you? What is your brain telling you to do, to reason, to kind of figure out this ratio? Take a minute and then you can share your thinking in the chat. Awesome. Before I share some of your thinking from the chat, I'm going to kind of go over here and show you what many of you are not doing. Many of you are not doing this. You're not setting up a proportion like this and then saying, okay, so 15x equals 12 times 25, and then kind of cranking this out, if you will, and then hoping to not make any computational errors along the way, right? So you're not using cross products, if you will, to solve this. You're using some reasoning in this table. I'm seeing many of you saying, like, ooh, I can't get straight from 15 to 25, but I could go from 15 to 5. Yeah, does that sound right? I could divide by 3, many of y'all were saying. Divide by 3, that would mean I could get 4 ice cream sandwiches for $5. Ooh, so I went down to 5. Well, now I can go, I'm going to add another 25 in. I could have gone back to the left, it doesn't matter. But now I could scale up times 5. to figure out how many ice cream sandwiches I could get for $25. And that would be something like 20. Does that look right, y'all? And you were describing it. Let me use some of the words that you used in the chat. Scale down to 5 by dividing by 3, and then scale up to 25 by multiplying by 4, right? So you're landing on this really big strategy, this really important strategy in proportional reasoning, which is called scale down to scale up, which might seem counterintuitive at first, right? Aren't we like, why would we go down if we're trying to get higher, if we're trying to get to 25? But that was a very strategic scaling that made that next scaling even easier. And this is an example of a strategy within proportional reasoning that we can use that makes problems much more easy to think about. And I would contend that this kind of reasoning that y'all were explaining here is much more accessible for many more students than a traditional algorithm that looks like this and that loses its context along the way and involves what could be much more cumbersome computation. So just something to kind of think about there in terms of the value of this particular strategy. There's another question in the string, but again, I'll just kind of show you an overview preview of what it looks like to show you that, again, we have this same structure of like, what is the question? What would I draw? How would I set this up? What questions do I ask? I want to draw your attention to a really important question in this particular string. In that second problem, I asked something like this. How would you explain how we found the number of freezies we can buy for $100, knowing that we can get 21 for $30? This is where I paused right here and made this strategy explicit by drawing it out from y'all to think about, oh, we didn't go straight from 30 to 100. We went from 30 down to 10 and then up to 100. And that kind of planted a seed that, hey, that's a thing we could do. That's a strategy we can use within proportional reasoning. Okay, thank y'all for kind of going on this journey with me in terms of these strings. I'm gonna hop back over to our presentation and kind of tie some different things together and have us reflect on some takeaways. So these are all the things we just did. Okay, so here's what I would like us to think about. I would like us to now come back to this idea of 2/3 x equals 12. 2/3 x equals 12. There are a number of strings in this resource, in this set of resources that look at how do we help students develop flexibility with solving equations. But I want us to think about how what we've explored here, ideas about iterating and partitioning, scaling down to scale up, show up within solving equations as well. So remember earlier we said we could think about this equation as 2/3 x equals 12. And so if 2/3 of x equals 12, we could partition that down to say, oh, 1/3 of x equals 6. Then we could iterate that up, triple it, so x must be 18. And at the beginning of the webinar, that might have felt like reasoning that was a little bit of a stretch or a little bit further than where we were. But even within this 35, 40 minutes together, we've looked at some number strings that would help lay the foundation for that kind of proportional reasoning, while also addressing many other content standards within middle school mathematics as well. And then if we can reason about an equation like this, then we can reason about an equation like this. And so we kind of come full circle back to, back to this idea of solving equations, but using reasoning. I want to kind of wrap up by having us think about there's so much more, right? So many more topics we could look at. We will not cover them in this webinar, but like, here's just a quick list. We could have number strings that reason about integer operations, algebraic expressions, all the other operations like addition, subtraction, multiplying, and dividing with rational numbers. There's so much more, but hopefully this gave you a taste for what a number string is, kind of how it works, and how it is part of a coherent trajectory of number sense within middle school mathematics. Our last question before we turn it back over to Kristen and the team for Q&A, one last thing I want us to do is to make explicit, to kind of share in the chat some different teacher moves that you observed. And I know it's tricky to observe because I wasn't on video, we weren't chatting live, I didn't get to see your videos live, but what teacher moves did you observe that made these number strings effective? Or you could think about what other teacher moves might you have observed had we been live or had we had cameras on, etc., to kind of do the work. What teacher moves we do? You can share those into the Q&A. Y'all are fabulous. The first 2 responses came in right away, and they're both wait time, which I was like, oh, I want to share that with everyone. And I'm like, but I better use wait time. So, so thank you for that and that little moment of irony. Absolutely, wait time is huge. And thinking about wait time when. So not every question gets the same amount of wait time. Some questions are set up to be pretty instantaneous, and then other questions are more of like, ooh, we need to dig in and think about this. So providing wait time for those. Other things y'all are making explicit, tell me more, explain your thinking. Cynthia shared that the questions that I asked were carefully planned to help us discover what I wanted you to discover. Absolutely, and that to me is one of the best, like most helpful pieces of these resources is that work of like, okay, what would be that pivotal, like pivot point question is done for us to help make that happen more. Showing the thinking, allowing students to discover, modeling the thinking with a visual like a ratio table, a number line. Questioning why to do one method or not another. Awesome, y'all are fabulous. These are all great takeaways about the teacher moves, even in an online platform where it might feel like there's some barriers between you and I. You're able to pick up on these really critical teaching moves that work so well face-to-face and online as well. Kristen, I think this is the point where you're like, okay, finished by this time. So do you want to hop back in? You said it much nicer than that, but you know what I mean? Like like build to a big takeaway, and then let's also have some time for Q&A.
Yes, perfect. That was great. Super, super helpful. Good information. The audience did so well. You guys did so well. You were very engaged. So kudos to you all too. Michelle, can you talk a little bit about manipulatives and using them at the middle grades, you know, in as it relates to math talks and number strings? But I think oftentimes there's a misconception that, you know, they're not as widely used as the, you know, students get older. Why are they still beneficial in 6th through 8th?
Yes, oh my gosh, I love this question. And like less people are like, okay, this was a pre-planned question. It is not. I'm sitting over here opening a manipulative right now. I'm like, oh, I've got an idea for how I could illustrate this. So I want people to think about, I'm going to actually answer this question through the example that I think is still showing on my screen. So if 30% of a number is 75, then what is the number? And what I'd like to push people to think about here is like, what's your brain doing right now based on what, excuse me, I'm sorry, based on what we've done in this webinar? Like, what is your brain thinking about to reason to an answer there? If 30% of a number is 75%, like what else do you know? Oh, sorry, if 30% of a number is 75, I'm sorry about that. What else do you know? And I'm asking you that question because I'm also kind of setting something up on the back end that I want to show y'all. Okay, awesome, thank y'all. Oh, neat. So y'all are saying like, I know 10% or whatnot. Let me jump over to my document camera for just a second. This is like totally off script. Kristen, I hope this is okay. So for example, I'm showcasing poorly because it doesn't fit on my paper. I guess I could extend this. Usually I'm smoother than those y'all, but this is like live action. I'm showcasing the magnetic percent bar diagram or manipulative that comes from Hand to Mind. This is a relatively new piece, which I love. And so you have different kind of components you can set inside this. So for example, we know in this case that 10% was, I even forget the question. Sorry, y'all, 75. So 30%, for example, is 75. And so some of y'all said, well, then I could iterate down or partition down to 10%, must be 25. Sorry. And so then if I know that, I could kind of fill in the rest of these pieces, if you will. to iterate up to show going to 50% and then going all the way to 100%. So to show that that would be like 250, for example, and there's all these different pieces that kind of fit in to show the percent bar model as a way to capture your thinking. So here, for example, we were dividing by 3, and then here we iterated 10 times as much. I could show that this way, or I could show that with 10 of these 10% pieces. But I think manipulatives are so powerful because they give us a visual model to hang our thinking on. So initially we can use them to kind of show how we're thinking or how we're reasoning about something. That's what we did live here in this like impromptu question, if you will. But then in the future, it gives us a visual model we can use for thinking. So in the future, then I could think about, oh, I could draw a percent bar model to help me make sense of what I know here. And then to think about how would I go from 30% to 100%? Maybe I would use this scale down to scale up approach that we used earlier on ratio tables. Kristen, you want to add anything else in on that?
No, I think that that's great. That was a very good on the fly representation. I'm glad you had that there manipulative handy because I don't know that I have my computer.
Yes, well, now there's pieces of it all around me because I was like in a flurry to find all the pieces, but I hope that was relatively smoothish to show what that could look like.
It was. That was great. The other thing, you know, why are number strings and math talks something that, you know, teachers can do anywhere? So regardless of what their instructional environment is at the moment, virtual, hybrid, in person, you know, how does this translate to any of those easily without a substantial amount of prep for them?
Yeah, I love that. I'm gonna back this question up as well. I don't have a ready-made example for this, except to say that what I love about number strings and math talks is how easy to implement they are. So for example, when I was first shifting my math instruction from a very traditional approach to something that was more student-centered and that like was meant to kind of put the agency and the and really the value back in student thinking, doing a math talk or a number string involved shifting 5 to 10 minutes of my instruction. So that felt like a very manageable lift for me. And so that's one thing, that's when I kind of set the stage with, like, there's such a powerful instructional routine in any setting because it's a relatively low lift, especially for teachers when we're doing so many things and so overwhelmed within a system, and can be so powerful for students. So then kind of pivoting to your question about, but like, what about the medium? I just found they've been so effective for engaging students, really pulling students into the conversation. And that works great face-to-face, but it can be so powerful, especially online, when students are feeling disengaged, especially if their instruction is typically like a live streaming kind of setup. This is a quick routine where students' brains are engaged, thinking, and then they feel like they're interacting within this conversation. And hopefully you experience some of that yourselves in this session as well, where you were like pulled into the questions and wanted to share your thinking about how you were reasoning to get there.
Perfect, perfect, perfect. I think that is it. The only other thing that I want to mention, number one, Veronica Alvarez is the winner. So I am going to, yes, and we have somebody from India joining who says this is really an impressive webinar. So kudos to you, Michelle. And I am so excited that we have somebody from India. That is awesome. Thank you for joining. So good, Veronica, you see that. Send me an email. You can just reply to the invite and it will come to me, and I will reply and send you, tell you what I need from you. You can choose any Daily Math Fluency Kit 6, 7, or 8. It is entirely your choice. So yay, it's always fun to win. But the other thing I was going to mention is that we do have, if you've been on our webinars in the past, you know that we have partnered with somebody or a company called Braining Camp, which is a platform that essentially has our identical, like our physical manipulatives in a virtual form. They are identical. They make them for hand-to-mind manipulatives. You can check them out by going to handtomind.com/Braining Camp. I am putting it in the chat right now, but I mention this because if you are in a virtual or a hybrid setting, sometimes the tools themselves, are a hurdle. How do I get these things in students' hands? Just showing, you may not have it at home, whatever it may be. This gives you another avenue. We have, I want to say there's 16 different manipulatives. They have individual licenses. So like if you had got an individual license as for the teacher, all of your students would be able to access it. There's a new share feature embedded where they can share, there's a link where you can kind of go back and forth and see each other's work. And it's just really, really cool. So yes, it is Hand to Mind. Just go to handtomind.com/braining camp. I did put it in there, but I will put it privately to you as well. And as a reminder, yes, you will get a certificate. If you attended the live webinar, that will come in the same email as the recording. So the subject line is "Thank you for attending." It will take several hours. So if you have not received it, in a few hours, don't panic. It will come. It just takes a little bit to process. So that will give you proof of attendance, and you can access the recording at any time. And if you have any questions at all, feel free to reach out to Michelle or I. We're happy to, if I get any questions, Michelle, I'll shoot them your way. But I thought this was a great webinar. You did a great job. It was good information, and we appreciate it. And thank you guys in the audience for being so attentive.
Yes, thank you, everyone. Appreciate y'all.
Yes, you guys have a great day. And we'll be doing another one in a couple weeks. So we hope you come again. Take care.